Let's try long division of polynomials, which corresponds to section 7.6 in your book. Okay, so if we were trying to divide 12x cubed minus 19x squared minus 25x minus 10 by 4x plus 3, the very first thing we want to do is divide this 12x cubed here by the 4x, okay? And that's going to leave us with the 3x squared. Now I want to multiply the 3x squared times the 4x, which is going to give me a 12x cubed. It should match this term above it exactly, as that was our objective. Now we multiply the 3x squared times the 3, which is going to give us a plus 9x squared. Notice I'm lining these up. And when I'm going to subtract now, so this the 12x cubed minus 12x cubed is going to give us a 0. The 19x squared minus 9, you got to be careful in the signs here, gives you minus 28x squared. Let's go ahead and bring the rest of this stuff down, the minus 25x and the minus 10. And we're going to repeat the process now. So we want to see how many times 27x squared can be divided by 4x, and that's going to give us a minus 7x. Okay. Multiplying the minus 7x times the 4x is going to give you a minus 28x. Once again, we match that term exactly. The minus 7x times the 3 is going to give you a minus 21x. And doing the same thing, we subtract minus 28x minus a negative 28x, which is 0. Minus 25 minus a negative 21, which is going to give us a minus 4. Once again, be very careful about those signs. That's the place you're most likely to get an error. And lastly, we just want to see how many times minus 4x can be divided by 4x, and that's going to be a minus 1. And we're going to do our multiplication by both things here. So minus 1 times minus 4x is a minus 4x. Matching once again, and the minus 1 times the plus 3 gives you minus 3. And when we subtract here, we get minus 10 minus negative 3, which is going to be a minus 7. So our solution can be written two ways: 3x squared minus 7x minus 1 with the remainder of minus 7. You'll also see this sometimes as 3x squared minus 7x minus 1 plus, and then we'll have a fraction, which is going to be our minus 7 divided by our divisor, which is 4x plus 3. Okay, so either of those is acceptable. Okay, and let's try one with synthetic division. If you remember, so the one restriction on synthetic division is our leading coefficient has to be a 1. So that means we basically have to have like a 1 here. So minus 2x squared minus 3x plus 12. And if we're dividing this whole thing by x plus 2, let's say. So do this with synthetic division. We just copy down the coefficients. So we have the 1 for the x cubed, a minus 2 for x squared, minus 3 for x, and a plus 12 for the constant. And we're dividing here by, and we want to be a little careful, we divide by the opposite of this. It's the value that makes the whole denominator 0. So it's going to be a minus 2. What we do is bring the 1 down, multiply that times that, so we're going to get minus 2 times 1 is a minus 2, and we're going to add these two. Minus 2 minus 2 is minus 4. Multiply the minus 2 times a minus 4, gives you a plus 8. Add the 8 and the minus 3, which gives you a 5. 5 times minus 2 is a minus 10. We add these together, get a plus 2. And now we're going to be 1 degree lower. That was our degree of the original numerator. So now we're going to have, this one's going to give me an x squared, 1x squared. The minus 4 is going to give me a minus 4x. The 5 is going to give me a plus 5. And we're going to have, plus 5. Should probably use an eraser, and this is going to be a remainder of 2. So you might check this one with regular long division and verify that you can do the synthetic division. It's, once again, it'll be less likely to get an error because you're adding rather than subtracting in there. One last little thing I'm thinking about that might help you out is, remember, if we're dividing x squared minus, let's say x cubed minus x plus 5 by x plus 2 in regular division, we want to be careful and put an x cubed plus 0x squared. We're just basically putting a marker for the x squared because we do not have an x squared term here, but when we do the long division we will get one. Okay, so just a hint, if you remember, you can look in the book. If you don't, that'll explain that. So when you're doing your long division, you want to have a placeholder for every x every value and the one previous to it, x to the first and x to the 0 power. Okay, that concludes this video. Thank you.